In previous video, we have seen how to detect the anions. In this video, we are going to see how to detect the cations. Cations are first separated into groups. So, let's see some examples of cation. There are lead, copper, iron, chromium, aluminum, nickel, zinc, barium, strontium, calcium, magnesium, aluminium and bismuth are some examples of cations. Now, these cations are grouped into six. They are in first group we have mercury, silver and lead. In second group we have bismuth, copper and cadmium. And also we have tin, antimony and arsenic. In third group we have iron, chromium and aluminium. Fourth group cobalt, nickel, manganese and zinc. In fifth group we have barium, strontium and calcium. At last, in sixth group we have magnesium and ammonium. In first group we have mercury and silver. They are, due to their cost, they will be not given to the practical analyzing students. So, lead is a common substances which is given to the students. And in also in second group, tin, antimony and arsenic are the rare substances which are given to the students. Before entering into analysis part, we have to eliminate the interfering acid radical. In before we have seen the interfering radicals such as oxalate, borate, fluoride, chromate, phosphate, etc. So here first we have to eliminate these interfering radicals and then only we can further test the cations. So to eliminate oxalate, we have to take the substance in a china dish and we have to roast it. After roasting, mix the dilute HCl and stir it well. After stirring, collect that sample. That sample is free from oxalate and further it can be used for other testing. Now, borate, fluoride and chromate comes under the same elimination method, such as substance is taken and concentrated HCl is added, and this mixture is tend to boil to evaporate all the HCl content. After that, the mixture is diluted with water and that solution is enough to do the further testing. So the toughest method in this elimination is to eliminate phosphate. So to eliminate phosphate, the substances is mixed with NH4Cl and zirconium chloride. While this mixture is mixed together, we will get a white precipitate. We have to remove this white precipitate. This method is repeated 2 or 3 times. After the white precipitate formation is stopped, NH4Cl and NH4OH is further added to that solution to eliminate phosphate. After eliminating, we are going to test the cations present in a sample. In test for cations, after eliminating the acid radicals, we obtained a centrifugate is nothing but our extract. First, we are going to test for lead. The extract is taken and it is mixed with acetic acid and potassium chromate. We will get a yellow precipitate. The yellow precipitate confirms the presence of lead in a given sample. Next, the extract is mixed with Ki solution and it is heated and it is well cooled. After cooling, we get golden yellow spangles which confirm the presence of lead. Here in this cation testing method, we are not going to use H2S gas and centrifuge machine. Without passing H2S gas and centrifuging, we are going to test all types of cations. Next, bismuth. Bismuth extract is mixed with dilute HNO3 and NH4OH solution, and further the solution is transferred into 20 ml of water to get a white turbidity. The white turbidity confirms the presence of bismuth. Copper. To confirm copper, the extract is mixed with acetic acid and potassium ferrocyanide to get a reddish brown precipitate. The reddish brown precipitate confirms the presence of copper. Next, moving on to ion, the extract is mixed with NH4CNS solution to get a blood red color. The blood red color indicates the presence of ion in a given sample. To test chromium, the extract is mixed with acetic acid and lead acetate. As soon as we get a yellow precipitate to confirm the presence of chromium. To test aluminium, extract is mixed with NH4Cl and it is heated to get a white precipitate which confirms aluminium. Nickel, extract is mixed with DMG solution, that is dimethyl glyoxime solution, and NH4OH solution to get a rosy red precipitate which confirms the presence of nickel. Barium, extract is mixed with concentrated hydrochloric acid plus dilute sulfuric acid to get a white precipitate which confirms barium. Moving on to strontium, extract is mixed with calcium sulfate solution. As soon as we get white precipitate which confirms strontium. Calcium, extract is mixed with NH4OH solution and NH4C2O4 thrice solution. As soon as we get a white precipitate which confirms presence of calcium in a given sample. For magnesium, extract is mixed with NH4OH solution and NH4Cl and it is mixed with disodium hydrogen phosphate to get a white precipitate. The white precipitate confirms the presence of magnesium. Next, ammonium. The extract is mixed with Nessler's reagent and some amount of NaOH is added to get a brown precipitate. To find ammonium, there is an easiest method. If we smell the given substance, we can feel the pungent smelling. So the pungent smelling indicates the presence of ammonium in a given sample. I hope you all have known something about inorganic qualitative analysis and the testing methods of cations and anions, and also some shortcut methods involved in this. So do support and subscribe our channel.